Okay, so welcome to Friday's Junior channel. Today we are going to have a discussion on basic mechanics, and then this is our first episode. We are starting on what resolution of forces in what basic mechanics. Now, and then we are tackling what 2D today. And when we talk about 2D, the main aim is to be able to resolve forces into what x and y. So our main aim is to be able to resolve forces. So this is our main force, F, which is more or less like the resultant force. And our main aim is to resolve this particular force into what x and then y, F of y. So this one is what a force at a particular point that is what inclined. So we have this particular FR at this point. Let's assume the angle it is making with the x-axis. We know this is x-axis and this is what our y-axis. The angle is making with it is what theta. So if you want to resolve this particular force into x and y, what you do is that you take the F, the main force, and now resolve it. So we have this, we have that. Now, anytime you know the angle to where you are going, you always use cos. And then if you don't know the angle to where you are going and it's fall between what 90 degrees, then you have to use sine, the opposite direction. So now that we know the angle to what the x plane, so the angle from where the force is to the x plane is also known as what the theta, and then we know it. So if you want to resolve f of x, then f of x will be the same as what the force itself. So f of what r cos, because we know the angle to where we are going. And then similarly, if you want to find the force in the y plane, so you realize that at this point you don't know the force to where we are going. Where we are going is what the y, which is this plane or that plane. Then in that case, you are going to use the same one, f of r what sine of what the angle. And this happened as a result of the fact that now if you have, let's say, a particular force here, we have an angle theta here, and then you have the main force f of x here, and then you have what f of y and what that f of z. Now let's look at sine. If you have sine of an angle, let's say sine theta, we know that sine is the same as what so, right? And we know that so is the same as the opposite divided by the hypotenuse, right? So it means that the opposite force in this case will be equal to what f of y, and then the what the hypotenuse is the same as what f of r, right? F of r, sorry. So if you want to find f of y, what you do is that what we know that at this point f of y will be equal to what f of what r what sine of what theta. Because we didn't know the angle to where we are going, the angle was what in terms of sine. That is why f of y we had it in terms of what sine of what theta. Similarly, if we want to find the value of s, we use the cos theta, and we know that cos is the same as what right? That is what the adjacent divided by the hypotenuse. So that means that what our our cos theta will be equal to the adjacent, which is this one, which is f of what x, f of x divided by what the hypotenuse, which is what f of r, right? Then it means that if you want to find f of x, f of x will be equal to what f of r what cos what theta. So anytime you know the angle to where you are going, which is this one, you always use cos. And if you don't know the angle to where you are going, you always use what sine. These are the two main parameters we need to put in mind. That anytime we don't know the angle to where we are going to use sine. If we know the angle to where we are going, you are going to use what we know the angle to where we are going, we are going to use cos, and that will make things more easier for us. Then I said that anytime we are dealing with 2D, our main aim is to be able to resolve a particular resultant force into what x plane and that of what the y plane. And then if we know that, then things become more easier for us. And then we can also use it in terms of our distances, right? So realize that in this question, we are going to tackle this question that we have before us today. This question they said that what find the resultant of the forces shown using the unit vector approach. Okay. Now, when we say unit vector, unit vector is the same as what? A vector divided by what? Its magnitude. And we know that, let's say if you have f of x at a certain plane, now f of x like this as a certain plane, this is a particular vector. So anytime they are saying you find the unit vector, that means I take the force itself and divide by what? The magnitude of what? That particular force. So assuming we have a number of forces, we have f of x and then that of what? F of y. Then it means that the unit vector of these two will be the same as the force itself, right? Divided by what? The magnitude of what? The forces, which is the what? The magnitude. And we know that the magnitude of this particular force in terms of 2D is the same as what? You've taken what? Categorize of what? The force being in the x plane, right? Plus the force being in what? The y plane. So the square of the two will give us what? The magnitude. And that is basically what we are going to do here. So it means that this question here are telling us what? To use the what? The unit vector approach. Okay. So anytime we have what? The distances, and then we resolve in terms of the unit vector, and we multiply by the main force, the resultant force, we'll get our results. Okay, so let's proceed with it. Okay. Okay. So here, the question states that we should use the unit vector approach. So this is what we should do. Anytime we are using the unit vector approach, we are always going to consider the center. And I said that if we have a vector that is, or a force that is inclined, and then we have to resolve it in terms of 2D. The main aim is to get the f of x plane and f of y plane. So what we are going to do here is that we are going to resolve this force because this force is inclined. So we are going to look at the amount this force will give us in the x plane and the amount this particular force will give us in what? The y plane. And then in doing that, you need to consider the unit vectors. Okay, so let's do that now. Okay, so let's resolve the force into f of x. We are resolving it into the using the unit vector. So it means that the force 800, the force 800 will be equal to the distance. So first of all, you need to look at the distance, and we know that anytime you are resolving the distance in terms of x, we always use what? I of what? X, right? And if it is in terms of the y plane, it's I of what? Y. So that's what we are going to do now. So here we start from the center, and our main aim is to be able to move to where the force is going. But I realize that we can't move here directly. So we have to move at a certain path. Either we move in the what? The y plane or what? The x plane. The main aim is to be able to move to where the force is going. And we realize that the force is going in this direction. Okay. So here this is the force. So we are moving to this side. So and then always you should put in mind is that now you can choose your direction to say that what? Anytime the force is going in the right direction, it is what? If it is going in the right direction, it's positive. And then if it is going in the left direction, it's what? Negative. Or you can choose vice versa, but you have to, whatever you choose, you need to repeat it throughout. Or to also say that if it is in terms of the y, if it is moving down, it is negative. And if it is moving up, it is what? Positive. So we can have our cardinal point and say that what? If it is moving down, it is what? Negative. If it is moving up, it's what? Positive. And if it is moving here, it is what? It is what? It is positive. And if it is moving here, it is what? Negative. Once you get this, you are done. But it doesn't mean that there can be a force here. And then when the force, there can be a force here. Let's say the force direction is in this way. And then if the force can be in this plane, so assuming we had a force here, like this, and the direction of the force is in this direction. If we resolve it into this plane, it's going to be positive because it's moving in the positive direction. Now the same force in that particular x plane moving this way, if you resolve it into this plane, it's going to be negative because the direction will be in the what? In the x plane. This is what we should know. Okay. So let's do the movement now. So we are moving to, our main aim is to move to this side. So we move from here to here. It's moving in the what? The x plane, right? So we call it what? The distance from here to here is what? 800, right? So that will give us what? 800 what? I of what? X, because it's in the x plane. And it's also what? Positive. Similarly, from here to here is what? Is what? In the y plane, right? So our main aim is to move to this side. So we move from here to here and then back to here. And then realize that it's moving upward. That means it's what? It's positive. Minus minus. It's positive, right? So that will also give us what? Plus what? And the distance is what? 600. So that will give us 600 what? I of what? Y. All divided by what? The magnitude, right? And we know that the magnitude is the same as we taking the root of what? This particular force. So that will give us 800 what? Squared plus what? The 600 what? Squared. So that is it. Then you just multiply whatever you have by what? The force. And in this case, the resultant force is the same as what? 800. Right. Okay. So okay, so that's it. You realize that. So when we finish, then we now resolve it into what? The x plane alone. The force in the x plane and that of what? The y plane. So let's do that now. So we can have something like the force 800 has two components. That is, it has what? The 800 root of what? 800 squared plus what? 600 squared component. That is what? I of what? X. Plus another force in the what? The y plane, which is what? The 600 divided by root of what? 800 squared plus what? 600 what? Squared. I of what? Y. When we finish, then we need that the first 800 is giving us a total resultant of what? So let me do it with my calculator. So all into bracket, multiply the entire force. Okay. So these are the main components. So we have the entire component is what? 800. Thank you. So we have 800 standing constant. We have 800 divided by root of 800 squared plus 600 what squared. Okay. So this will give me a value of what? 640 pi of what? X. And then the other one will give me a resultant of what? Okay. So that will also give me what? 480 what? IY. So this is just telling us that what? This F component, the 800 component is giving us what? A particular force in the X plane and another force in the Y plane. So after that, we move on to find the other force. So we have a number of forces here. When we finish, we'll add all the forces in the X plane. And then we display that particular force here. And we add all the forces in the Y plane, display it here too as well. So let's now move on to the another force. We have force what? So we are now going to do it. So we can now clean this one. So I have my resultant value was what? All the values. So the force 800 was giving us what? 640, right? Ix and what? 480, right? Iy. Okay. So the next thing I will do is to find the F of what? 4 408. So 408 resultant. So the 4082, the force is moving in this direction. So that means it is coming here. This is what? This one. Okay, 800. So now let's move on to the force what? 480. Now in the force 480, realize that what? It is moving into this particular point. So what you do, your main aim is to move to that end. So we starting from what? Your center. So in this case, we can choose to move this way and move that way, or move this way and move that way. We get the same results. So let's say I'm moving this way. So from here to here will give me what? A distance of what? 900. So that will give me, so and the actual force is 408 bracket. From here to here will give us what? 900, right? But realize that the 900 is moving down. So we are moving down. That means what? Negative. I of what? X. And then after that, you move on to this side, which is what? Which is what? Positive value. So plus what? 4 what? 450 what? Ix. Because it's in the what? The what? The right direction. Of course. Yes. Positive Iy. Sorry. Okay. This one was in the y direction. So this one will give us what? Y. And this one was in the what? The x direction. So this one will give me x. All divided by, so I can do it individually so that I'll be free. But then let's just do it all divided by, because the vector divided by its magnitude. Root of what? So we don't need to do it as negative. So that give me the 900 squared. This is just telling us that the direction was in the negative region. Plus what? 480 what? Squared. Just 450, right? Okay. So it means that my force what? 480 will now be equal to the calculator 408 bracket minus 900 all on what? Root of what? Root of 900 squared plus 450 squared. Okay. And that'll give me negative 364.9 what? 3 I what? IY, right? IY plus, I don't know what the results I'll give. I know that it's positive. That'll give me a root of, and then 450, right? 450 squared. And that'll give us what? 102 point what? 5 what? Ix. So 182.4 to 0.46 what? Ix. Okay, very good. So it means that I can present another force here. And in that force is what? Our force what? 40 what? 8. And the values are what? 100 and what? 82.46 what? Ix. Plus or minus, sorry. Minus what? 300 and what? 64.93 what? Iy. Okay. So we are going to now solve for the last force because we have another force in a particular plane. Yes. Okay. So we are looking at force what? Force 4 what? 2 4, right? Newton. So this force 4, this one will give us what? 424 bracket. We are now going to consider their distances. Okay, we are now going to consider their distances. In their distance, we realize that the force is moving to this end, right? So we are going to do our movement. And I said we can either move this way, right? And then finally move to this end, or move this way and move to that end, which will get the same result. So moving to this side will give us what? Negative, right? So that will give us negative. So or let me do for the x first, right? So that it will be uniform. So I can move this way. That will give me what? Positive, right? Negative. It's moving in the negative region. So that will give us negative what? 500 I. And this is the same way thing we are going to do in the what? In the 3D plane too as well. And after that, we move on to it. The downside, which will give us what? Plus what? 900 what? I what? I y. We are moving negative. Very good. So this one will give us negative because we are moving down. All divided by what? The resultant, right? Okay. And the resultant is what? 500 or the magnitude plus 900 what? Squared. Okay. So we now look at the individual components. So this one I'm going to do straight. This one will give us 424 bracket. So this is 500 divided by root of what? 500 squared plus 900 squared. Okay. So this one give me what? 205.9 I what? X. And then I will only, so that will be negative. And then I have what? Minus, right? 900. So this one will also give me minus what? 370 what? I what? X. So you realize that this another force here has been giving us what? Force what? 424, right? This one is what? IY, sorry. Has given us what? Minus 200 and what? 5. 205 what? IX, right? 0.9. 0.9 what? IX. Minus another negative. Minus 370 what? IY. So when we finish, what we do is to add all the X. So our resultant force, our main force, which is the resultant. This is our result. This is not the magnitude, the resultant. You add all the forces, right, in the X region, and then all the forces in the what? Y region. There is difference between resultant and what? The magnitude. So that will give us what? 640 plus what? 1282.46 plus what? Minus, will that give us minus what? Point what? 9. And that's giving us a total of what? 611. 6.56 what? I what? X. So we don't know as to whether it's going to be positive or negative. So 480 minus what? 364.93 plus what? Minus 370. That's giving us what? Minus 54 what? Minus 254.93 what? IY. Now this means that what this means is that now what we have here means that what? We have now resolved these forces into what? X and Y plane. So this is our resultant force we have here, R. And then the x plane of the force is what? 616 what? 0.56 what? Ix. And that of the y plane is what? Negative. So you can just write it like that. So the y plane is giving us what? 254 point what? 93. And this is the resultant force. So assuming you are told to find the magnitude. So this question says that what? Find the resultant of the what? Forces. So we just need this one alone. The question can also state it again clearly that what? Find the magnitude of what? The forces. What you do is what? To find the what? The Pythagoras form of it. So the magnitude of the forces will now be equal to what? This, right? That will give us what? 616.56, right? Squared plus what? 254.93 what? Squared. Now let's assume another question. The question says that find the angle the resultant is making. That means that the angle the resultant is making with what? The x-axis. And that means that you can just take the force and what? Resolve it into this plane, right? And then when you resolve it, now it means that it will be equal to the force here. You see that? Because we know that we said that anytime we know the angle to where we are going, we resolve it what? Using what? Cos. Or you could equally use this and this to find the angle here. And that's the angle the force is making with what? The x-axis. Thank you very much. And that is all for what? The 2D resultant. We'll move on to the 3D. If we understand this one clearly, then it means that the 3D will actually be more easier for us. Okay.